That small pink cylinder floating in cloudy liquid inside a tin can. You have seen it your whole life. You have probably eaten it without thinking twice. And almost everything you assume about what is inside that can is wrong. Somewhere in this factory, there is a single machine that takes recognizable meat and turns it into something you would never identify as meat again. That is not an exaggeration. We'll get there. Raw material arrival and selection. A refrigerated truck backs into a loading dock before most people wake up. It is carrying what the industry calls raw trim. This is not a clean steak. This is not a whole chicken breast. Raw trim is the leftover portions from larger meat processing operations, pork shoulder offcuts, chicken pieces, beef scraps, the parts that never make it to a supermarket shelf as whole cuts. It arrives chilled, sorted by fat content percentage, and weighed on entry. A Vienna sausage factory needs a precise fat-to-lean ratio in that incoming material. Too much fat, and the finished sausage collapses in texture. Too little, and it turns dry and crumbles. This decision happens before a single machine is switched on. Grinding. The trim moves into a grinding room, kept at near freezing temperature. The cold is not optional. Warm meat smears instead of grinding cleanly and loses its structural bind. Workers in that room wear heavy insulated gear. The meat goes through a coarse grind first, breaking it into rough chunks, and then immediately into a second, finer grind. By the end of that second pass, the material looks nothing like it did on arrival. It is a rough paste, unrecognizable. But you are still nowhere near the most extreme transformation in this process. Secret step. Seasoning enters next, and this step is more precise than most people would ever guess. Salt goes in first, not primarily for flavor. Salt at this stage is pulling a specific protein out of the muscle tissue called myosin. That protein is the binding agent. Without it activating correctly here, the entire batch would fall apart later. After salt, a dry blend goes in. White pepper, coriander, garlic powder, a measured amount of sugar. These ratios are not approximated. They are weighed to fractions of a gram and folded into the mixture by a mechanical mixer running at a controlled speed for a controlled number of minutes. Undermix it and the seasoning sits unevenly. Overmix it and the protein structure breaks. Then, ice-cold water is added in stages while the mixer runs. This seems wrong. You are adding water to something that needs to be solid, but that water is loosening the protein matrix just enough to prepare it for what comes next. Stuffing and casing. Remember what I mentioned at the start? The step where the meat disappears? This is it. The seasoned, mixed, hydrated blend is fed into a machine called an emulsifier, and what comes out of the other end is not recognizable as meat in any way. The emulsifier runs at extremely high speed. It reduces everything, every fiber, every particle to a smooth, pale pink paste. The fat becomes microscopic droplets suspended evenly throughout the protein. Individual muscle fibers are gone. Texture is gone. What you have is a batter. That is the base of every Vienna sausage you've ever eaten. Not chunks, not chopped meat, an emulsified paste. And here's the part that genuinely changes how you see this product. The real Viennese sausage from Austria that gave this product its name is nothing like this. The original Wiener is smoked whole ground meat with visible texture and a firm bite. The American Vienna sausage has no connection to that. It borrowed the name and built something completely different. Vienna, Austria has nothing to do with what's in that can. Smokehouse. The paste is pumped into a stuffer, a pressurized machine that pushes the material out through a tube in a continuous, perfectly uniform stream. The casing that receives this paste is not animal intestine, like traditional sausage. It is a tube made from cellulose, processed plant fiber. The paste fills it continuously, and the machine ties off sections at the exact target length. What comes out looks like a sausage. It has the shape, it has the diameter, but it still needs heat. Peeling and brining. The filled links enter a smokehouse. This is a controlled oven that runs in stages. First, low temperature and high humidity. This sets the outer surface and prevents splitting. Then temperature climbs and real smoke is introduced. Hardwoods like hickory and oak are common. The smoke adds flavor, but it also deposits compounds on the surface that slow bacterial growth. The smokehouse cycle is timed precisely, and internal temperature of every link is monitored continuously. The USDA requires that internal temperature to reach a fully cooked threshold. Not nearly cooked, not mostly cooked, fully. By the time these links come out, they are already safe to eat. Canning and retort. But the casings are still on. The links travel through a hot water shower that loosens the cellulose layer. Then they pass through a mechanical peeler, rollers, and a stripping mechanism that removes the casing in one clean motion without tearing the sausage underneath. That smooth, seamless surface you see when you open the can, that is not natural sausage skin. That is the paste itself, set firm by heat, now exposed directly. From there, the sausages go through a brine bath, salt water, and this is what fills that can. The liquid you assumed was juice or flavor liquid is a preservation brine. Its salt concentration suppresses bacterial growth and extends shelf stability significantly. The sausages absorb a small amount of it during soaking, which is a significant part of the sodium content in the finished product. Canning happens next. Sausages are counted and placed into open steel cans by machine. Fresh brine floods each can to a precise fill level. A seamer machine crimps a lid onto every can under pressure, creating an airtight seal. The sealed cans enter a retort, an industrial pressure cooker running at temperatures above boiling. This is the final kill step. The heat destroys any remaining microorganisms and creates commercial sterility. That sterility is the reason a can of Vienna sausages can sit on a shelf for 2 to 5 years without refrigeration. After the retort cycle, cans are cooled with water, dried with air, and moved to labeling. A high-speed label machine spins each can and presses the label flat in a single motion. A vision system checks placement. Cases are built, pallets are stacked, and the product ships. Scale and numbers. Right now, over 300 million cans of Vienna sausages are consumed in the United States every single year. One factory running at full capacity can produce over 1 million cans in a single day. Every one of those cans went through at least 14 distinct processing stages. Every one of them started as raw trim on a loading dock and ended as a fully cooked, commercially sterile, shelf-stable product that needs nothing from you except a can opener. The next time you open one of those cans, you'll think about the emulsifier. You'll think about the paste that used to be neat. Drop a comment below. Did you already know the liquid in the can was salt brine, not juice? Because most people are genuinely surprised by that. And if this is the kind of factory breakdown you want every week, subscribe. A new process is already coming.